Section 4.1. More angles in degrees. And radians. Now, the first thing I want to talk about very briefly is showed up in your assignment yesterday. It said to graph these angles or measure these angles that were in standard position. And standard position just means that the angle starts along the x-axis. So I'm going to label this the x-axis, but I'm also going to call it the initial side. And then if you're talking about an angle that goes all the way to here, this side right here is called the terminal side. So an angle is made up of an initial side and a terminal side, and it's in standard position if the initial side is right on the x-axis. Okay? Shouldn't be a huge deal. We need to talk about coterminal angles. Coterminal angles. Coterminal angles are angles that have the same initial and terminal side. So a coterminal angle is an angle that has the same starting value or the same starting point and it has the same finishing point. So for example, let's say that you have, and I'm going to start off talking in degrees, and if I ever give you one of these things in radians, and radians are too much for you to wrap your head around, what should you do? Change it to a degree. It always makes more sense. It still makes more sense to me in degrees too. But let's say that you have this angle right here. We'll just make it easy and say it's 45 degrees. We're talking about this angle right here, 45 degrees. What would be another angle that is coterminal to this angle?
30. 45.
Has to have the same initial side, and it has to have exactly the same terminal side. It has to start and stop at the same spot.
45. 45.0.
90.
45.
Well, if it's 90 degrees, I would start here along the x-axis, but then I would go up to here.
Yeah, but then.
And I wouldn't have the same terminal side.
Yeah, negative 45.
Negative 45 would put me down here.
So then why isn't it 45?
So there is no way.
Well, I'm telling you that the... Okay, all right. Let me just tell you. Okay?
Wait.
405.
405?
Degrees.
405 is correct. What did you do,
I
Jacob?
went around, did one revolution.
Yes, you went all the way around. So you're at
Whoa.
45 degrees.
Whoa!
You go all the way, continue to go all the way around again and stop where you initially had stopped. All right? So you have 45 degrees. You add on to it 45 degrees. You okay with that?
So we're gonna feel so smart right now.
You do? All right. What else could you do though? I mean, I could keep going. I could add another 360 degrees. I add another 360 degrees. Add another 360 degrees. What else could I do?
Could be negative.
Yes, you could go the other way.
Good job, Lewis.
You could go the other way. What would I do to go the other way?
Make it negative.
Well, make it negative, yeah, but what would I do to the 45 degrees if I'm going to go the other way?
Negative 360.
You're going to
Subtract 360.
subtract 360 degrees.
Flush it.
Yeah.
No.
Yeah, but what does that equal, Jacob?
So, Let's say you are talking again about a 45-degree angle. Let's write that down. 45 degrees. Angles that are coterminal to this, a coterminal angle would be if you took 45 degrees and you added 360 degrees to it. What's 45 plus 360?
405.
405 degrees. All right, so 405 degrees and 45 degrees would be considered coterminal angles. Yes?
Yep.
All right, what else could I do? What else could I do to the 45 degrees,
Subtract.
Luis?
Subtracted by 3 degrees.
Subtract 360 degrees. So can someone do that? What is 45 minus 360? Negative 315 degrees. When you get a negative number, what does that mean to you? You went clockwise. Very nice. Thank you for doing that, by the way. All right, so, and you, by the way, if you have this 405 degrees, you could find another coterminal angle by adding
720.
another 360 degrees. Yeah, so in other words, adding 720 on to the 45. Every revolution is considered a coterminal angle. Oh, you guys are on fire today. I love it. All right.
Well, put me out.
We already talked about radian measures. Yeah. Yes. Okay. She's gonna puke.
That's on the recording. Come
I
on.
know, but wow. Okay.
It's just.
We don't know. No one knows who it is, so it's okay.
All right. Here we go. We have an x and a y axis. We have a circle right here.
Yeah.
That's the unit circle, the 1 unit circle.
Yes.
Agreed.
And okay.
Too high.
So this is the center. So the distance from here to the outside of the circle, we call that r. Yeah. Why am I calling it r?
Radius.
It's the radius of the circle. Yeah. So let's say that I draw another radius right here.
Yeah.
So that's also called an r, a radius. All right, so we have a radius, we have another radius, and I purposely drew that second radius right there because I wanted it to look like this arc that I've created is also the same length as the 2 radii that I just drew. So this is an R also. So yeah, we have something. It looks like a piece of pie, kind of trapped between 3 equal radii. Radii is plural for radius, so I'm talking about 3 radiuses, 3 radii that kind of are trapped and they make up a piece of pie. Are you with me here?
Yes.
Does anybody remember what this piece of pie is called?
A piece of pie.
It's made up of 3 radii, so we call it a
Radian.
radian.
A tridie.
We call it a radian.
Nice job, Ricardo.
And it just so happens that regardless of how tiny or how large the circle is, if you take a radius and a radius and a radius and you make this piece of pie out of it, you will always get this angle right here will always be exactly the same measure. And it's not 45 degrees. It is, it's actually 57.
Yeah, but you made that up, so.
I did not. I did not make it up. 57.3 degrees is the measure of 1 radian. So when I
Always?
say to you
Is
guys,
it always it?
it's always that, regardless of how little or big the circle is. When you have a radius, and a radius trapped to make that piece of pie, the angle that it creates inside is always it's like 57.29, blah 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 blah. So we're gonna say it's 57.3 degrees. Okay?
Yeah.
So this right here, this arc right here, this point right here on your circle is 1. It is 1 radian. So it just so happens. It just so happens that if you have a radian and then another radian and then another radian and then a little bit more, you get to right here, which is called pi. which is equivalent to, what does pi mean?
180.
Okay, what is the decimal value is what I mean?
3.14.
So when we say that this is pi, we mean that it is pi radians, which is the same thing as 3.14 radians. That's why we call this spot, when we've rotated 180 degrees, we label that as being pi radians, because you can fit 3.14 radiuses at the point at which you get to 180 degrees. Yes?
Can you spell radii?
Michael, can we try to be
I'm serious. That's in my
R-A-D,
notes.
R-A-D-I-I.
Okay.
R-A-D-I-I.
Being
Okay.
serious.
All right. This angle right here, by the way, is a radian, but it's also called a central angle, and we talked about those a lot last year.
Yep.
Central angles are angles that are located in the center of the circle. Yes. All right. If you go all the way around a circle, starting right here, and you go all the way around. What are we finding of the circle? What is that called?
The circle.
The circumference, yes. What is the formula for finding the circumference of a circle?
2 pi r.
2 pi r. So if you go all the way around a circle, you take 2 pi. Do you understand what I'm saying here? 2 pi r. R meaning the radius. If you go all the way around the circle, you find the circumference of the circle. That means that's equivalent to having 2 pi radiuses. You could wrap all the way around the circle. That is why we call this point right here 2 pi radians. 2 pi radiuses. That's what that means. What's the matter? All right. We've already talked about what a degree is. We've talked about converting things from degrees to radians, radians to degrees. We've talked about coterminal angles, right? I would like to talk about what it means for angles to be complements and supplements of each other. All right, so let's talk about a complement first. And when I say a compliment, I don't mean when you say something nice to someone. That kind of compliment is C-O-M-P-L-I-M-E-N-T. This is C-O-M-P-L-E, complement. What does that mean? When two angles are complements of each other, that means that they do what? Very good. No. 90, yes. Complement means, and it's really important too that you know that it means two angles. It can't be three angles that add up to 90 degrees. It has to be two angles that have a sum of 90 degrees. Two angles that have a sum of 90 degrees. Supplement. Well, if a complement is two angles, excuse me, that sum to 90 degrees, what is a supplement? Sounds like I'm going to write that. They have to add up to 180. But again, it has to be two angles that have a sum of 180 degrees.
Is there a word for two angles that have the sum of 360 degrees?
Not to now.
A circle.
Yeah, a circle. There you go. All right, by the way, when I say 90 degrees, what is 90 degrees in terms of radians?
1.5.
Pi over 2.
Pi over 2.
Almost 1.5.
A half of a pi. Yes. A half of a pi radians. I'm just going to make a note of that. What about 180 degrees? How many radians is that?
1 or 3.1.
1 pi.
Okay, or just we can just say pi?
Yeah.
Pi, same thing. 180 degrees means pi. Now, like I said before, if you have a problem and it's asking you to find the complement of some angle, and it gives it to you in terms of radians, please by all means change it to a degree, and then switch your answer back to a radian, okay? Or just do it in terms of pi, in terms of radians too. Okay, a couple of examples. Let's find the complement. Find the complement of, let's do the complement of 2 pi over 5. All right, so first of all, you need to understand the word complement. We said complement means two angles that add up to 90 degrees. All right, so if I'm giving this to you in terms of radians, that might be a little bit confusing to you. So you may want to change it back to a degree, or change it to a degree first. So we've got 2 pi over 5. We're trying to find its complement. That means they have to add up to 90 degrees, which means they have to add up to pi over 2. So what we're really doing is taking pi over 2, we subtract 2 pi over 5 from it, and you will have its complement. So if you are given one angle and we need them to add up to 90 degrees, we take the 90 degrees and we subtract the angle that we have from it. That will give us the leftover that will make up the rest of the 90 degrees. So this is what you're really doing. But like I said before, if this is too much and you don't want to deal with the pies, then don't. I am going to deal with the pies. Pi over 2, if I could switch pi over 2 so that it had a denominator of 5, this wouldn't be that big of a deal. How can I make pi over 2 have a denominator of 5?
Multiply it.
Now if I put a 5 on the bottom, how many, what would have to go on the top?
2.5.
So in other words, I have 1 over 2 pi. You know what, I'm rethinking my decision right here. Let's do this instead. This is 1 over 2 pi. Let's subtract from it 2 over 5 pi. Ignore the pi's for a moment. Ignore the pi's. Just take 1/2 minus 2/5. 1/2. So 1 divide 2 minus 2 divide 5. Change your answer back to a fraction.
1/10.
You get 1/10? Okay. So you end up with 1/10, but then of course we're talking about a pi. So that means that if we add together 2 pi over 5 and 1 pi over 10, we are going to get what?
90 degrees.
We are going to get pi over 2, we're going to get 90 degrees. I want to talk about this problem now in terms of degrees, because I want to make sure that if this is too confusing, then I want to talk about it in terms of degrees. Yes?
If you multiply the denominator by 2, what is the revolution?
If I multiply the denominator by 2, will it be a revolution?
Yeah, it's like, if it's 1 pi over 10, if it was like 1 over 20, would it be the revolution of the circle? You understand? We've lost. I understand, but it's, yeah.
All right, let's change 2 pi over 5. Let's change it to a degree. So take your 2 pi over 5. How do I change this to a degree? What was the multiplying that we had to do?
Multiply 180 divided by 5.
Multiply by 180 divided by pi. And remember, it has to be the 180 over pi because you want the pi's to cancel out. You have a pi on the top, a pi on the bottom. So we get them to cancel out. So you're going to multiply 2 times 180 degrees divided by 5.
72.
What is 2 times 180 divided by 5?
72.
We have 72 degrees. So 72 degrees is what we're trying to find the complement of. So now we're going to take 90 degrees. Does everybody understand why I'm using 90 degrees right now?
Yeah.
What is 90 degrees? What does that mean?
The complementary.
We have to add, yeah, the two angles have to add up to 90 degrees. I know one of the angles is 72. So if I do 90 minus 72, I'm going to get 18 degrees. Yes?
Yeah.
18 degrees. So if it's 18 degrees, let's take 18 degrees and change it to a radian. How do I change 18 degrees to a radian?
Divide by 180.
Divide by 180, yeah. Multiply by pi over 180. So take 18, remember you ignore the pi, you just do the 18 divided by 180. What do you get?
110.
Yep, you get 1 pi over 10. Isn't that what we got when we did this over here? So working with a radian measure is not horrible. Notice all I really did was just take those two fractions, subtract them, and put a pi in my answer. But if it makes more sense for you to, to change it to a degree and do it that way, you're certainly welcome to do that. All right, I want to show you one more example, and then we're done with the example. So, I want you guys to find the supplement of 7 pi over 8. Find the supplement of, what did I say, 7 pi over 8? Find the supplement of 7 pi over 8. Supplement, what does that mean?
180.
180, which really means pi. So if I took pi and I subtracted from it 7 pi over 8, so in other words, you're taking 1, take this 1, and you're going to subtract 7/8 from it.
You get 1/8.
You get 1/8. 1 minus 7/8 is 1/8. Yeah, and leave it as a fraction.
Okay.
So you would get 1 pi over 8. This right here would be the supplement of 7 pi over 8. I want to do it in degrees too, so if you guys could, this is good practice anyway. 7 pi over 8, let's change it to a degree. 7 pi over 8, multiply it by 180 over pi. The pi's cancel out. Multiply 7 times 180 divided by 8. 157.5. That's a terrible number. 157.5 degrees. So now that is my degree measure. What did you say?
You'd expect to be close to 180 anyway, because almost.
Yeah, exactly. Yep. So now I have my degree measure. So I'm going to take 180 degrees minus 157.5 degrees. These are both degrees. What is 180 minus 157.5? 22.5, am I right, you guys? 22.5 degrees. So now if I change 22.5 degrees back to a radian measure, what should I get?
1 pi over 8.
You should get 1 pi over 8. Yeah, so I'm going to do that quickly. 22.5, multiply that by pi over 180. Remember that means ignore the pi, and all you're really doing is taking 22.5 divided by 180.
You get 1/8.
You get 1/8. Thank you. So you end up with 1 pi over 8, which is exactly what we came up with over there too. So this process, if you can get past the fraction part of it, is not bad. Because you know what? When you change it back to a degree, you're working with fractions anyway. So why not just do it right from the start? But, all right. Are there questions about what I just said?
No.
You feel like you can handle an assignment right now?
No.
It's Friday.
Yeah.
It's Friday.
It's Friday, so yes, you can handle one, right?
Look or
Same for Monday.
No, this is Patrick.